I am going to be looking at here is the body-clothing interaction between a surfing wetsuit and my body. What happens if I'm in the middle of the ocean, see somewhere I want to catch a huge wave, and suddenly as I'm on top of the wave, my suit restricts me. My motivation was basically that, trying to figure out what is the stress, strain on a wetsuit, how can I monitor the interaction without having to cut up the wetsuit. So what we worked with was the IBV Move 4D scanner. What we decided to do was capture a surfing movement, which is called the surfing pop-up, which is as if the rider just jumps up on the board, and then a little bit of movement after that, and then capture the dress scan with the wetsuit. This is a 5 millimeter thickness winter wetsuit with a hood. There's data gaps down in the red areas. There's also one more thing, which is the location of the person's eyes. I think this is probably the most important one because most scanning setups don't accommodate for a very low to ground scan. These are probably the biggest drawbacks in the scanning phase. So we're really taken down to two kind of approaches. So take the APOS homologous meshes and use it for FAM. And the other one is run a whole manual mesh generation algorithm from the start. So taking the point cloud data, which is always available, run a meshing algorithm. This is very simplified. Scanning myself naked, and then on the same APOS scan, I basically take the suit off of me, just transform all of the seams from the actual suit as I'm looking at it in Blender. This is the picture on the left with the red lines. Each panel on the bottom right is taken as a 3D panel, created a surface mesh out of it, flattened into a pattern to arrange all of the garments into the suit onto my same avatar that they were taken from, so there's no discrepancy or anything really there. Doing a whole material analysis process. So a wetsuit is purely rubber, right? It's rubber poured and then let it's cooled down. The whole structure is porous, kind of grainy structure. Grab a couple pieces of actually newly bought wetsuit, and test them. This one is actually, this is called the FAB Fabric Analyzer by Browseware. That this was not enough. We decided to do the old school classic tensile testing. We did two tests, one of them completely dry, as you would just put it on, and one of them soaked into distilled water. On top you can see the classical tensile testing results, 3 graphs at once wet, and that was expected. The wetsuit is taking much more or very much higher values of elongation. We can then input all of that into the simulation software for the clothing, and we can make this guy into something that looks like that. Now you can see on the left this is a fit map or a tension map. On the right we have a pressure map. The fit map is showing perfect values. The values that we're getting on tension, about grams per centimeter, are actually corresponding to a perfect fit. Fit was perfect, but I was feeling a little bit too much pressure, which is exactly what we're getting from the simulation as well. These are exactly the areas where I was getting pressure, mostly in the shoulder, and actually that was what we were aiming to see. Wetsuits have a big problem because they need to be very tight in order to keep you warm, and the shoulders are always very tight. Especially the shoulder is probably the most important part. People cannot pop up on your board with your shoulders, you can't really surf. Especially professional athletes, where at the peak of the sport really need to make sure that they're comfortable, especially when they're serving waves bigger than this building. That was me. Thank you very much for your attention, and I'm open to any questions. The Move 4D scanner can capture backflips, which is nice. And yeah, thank you.